5.2 proportions. I like this section. Proportions are great. I think we use proportions more than we think. We just don't really address them as proportions. In fact, we use proportions in that last unit quite a bit, especially with unit rates, right? Like if we were to look at that unit rate we saw for this one, right? If we said, well, this is, what was it? 0. What the heck was it? 202 right there. 0.202. Now this was rounded. So, I mean, they're approximately equivalent, but this is actually considered a proportion, you guys. Well, sorry. This one. This is considered a proportion because a proportion really is just two fractions that are equal. Now, we've talked about this before as well with, I think we used a sandwich. Maybe it was brownies. Right? If you had a pan of brownies, and let's say that I'm just going to use green because it's quick. Brownies that are green, whatever. Well, you could have, this is one piece of brownie right here out of what would have been two pieces, right? Now you could say that's half a sheet of brownies or whatever. Doesn't really matter. But let's say that I took the same sheet right here like this, okay? In fact, maybe I can do that a little bit better because technology. There we go. So I got the same sheet of brownies, but in this case, now it's been split into this many pieces. Well, in the first case here, I had one piece out of two, whereas in the second case, we can see now it's been split up into two pieces right here. But how many pieces were there originally? 4. Well, are you getting more brownie in either case? No, it's the same amount of brownie, which means that these two fractions actually are equal. And again, that's what a proportion is. It's looking at two fractions that are equal. So proportions are equivalent fractions. That's great. They're just equal fractions. Now, these are not minus sign, you guys. Minus signs. It's not a minus sign equals a minus sign. Those are fraction lines, right? So you'd have some values like this. A over B equals C over D. That is proportional because the two fractions may be equal. Now again, just like we compared in that last example, these numbers don't have to be the same. 1 over 2 is the same as 2 over 4. But are there any other fractions, like just compared with 1 over 2, right? Are there any other fractions that would be equivalent to 1 over 2 but not using the same values? Yeah, there is an unlimited amount, right? Now the next one I would think of would be, well, just move up 1 for each, so that'd be 3. I'm looking at the numerator. Well, if the numerator is 3, then the denominator would be 6. And this would be also equivalent. So equivalent fractions, it's not always 2. In this unit, in this section, we're only going to be comparing 2 fractions at a time. But you can have 3 fractions that are equal, and this would be considered a proportional relationship. Now, of course, like you said, there's infinite numbers, so you could say, well, I'm going to compare 100 to 200. All right, that's still equivalent to 1 over 2. It's just a matter of, well, which one is more useful for you, right? And I suppose, construction uses this all the time. I don't know if anyone works in construction, but instead of using a denominator of 2, maybe it is more useful for you to use fourths. So if you're adding 2/4 or 1/2 to 1/4, it may be more useful to compare this in fourths. So we've seen with addition and subtraction of fractions specifically, where we've scaled fractions to be a certain denominator, right, to allow us to use those operations of addition and subtraction. And yeah, it may be necessary to change the denominators into specific values so that we can operate with those values. And again, it scales the numerator proportionally. So again, the 2, if I said, well, I want 200, I'd multiply that by 100. Scaling the numerator proportionally would make that 1 times 100, which is 100. And again, it all depends on what value you're trying to get. Now that's scaling these fractions, which is a pretty common method. So the first types of questions, though, we're going to encounter is, are sets of fractions equal? So I prefer to see like a question mark over these when it's like, is it actually proportional? Or what we're really asking is, are these two values or two fractions actually equal to each other? Well, I use a calculator to make that determination, guys. So when I see 5 over 6, I actually want to compare the decimal value because for me, it is easier to use the decimals most of the time. We'll look at this one both ways, right? So in my calculator, I do 5 divided by 6, which shows 0.833. I mean, we know that 3 repeats, but this should be enough, okay? Well, what about 35 over 48? Again, I'm just going to put this into the calculator. Now, when I push enter in my calculator, I've got 35 divided by 48. But when I push enter, I need the exact same decimal that the last answer shows me. So where this one shows 0.729 and some change, I can see right away that these two are not equal. So are they proportional? No, they are not. Now, for me, that's the most convenient. But some of you guys may have seen, well, I can scale the 6 into a 48 pretty easily, right? And that would also work. Here's what I mean. So I know that 6 times what is 48? Well, 6 times 8. So scaling this fraction, I would take the 5 and multiply it by 8 also. Now 8 times 5 is 40. 6 times 8 is 48. So just like we've seen before, the denominator tells us how big the piece is. The numerator tells us how many pieces there are. So now that I'm comparing the same size pieces, this becomes, well, for me a little bit easier. Because I have the same size pieces, just how many are there? Well, this one has 40 pieces. This one has 35 pieces, both of the same size, and I can see that they are not the same. So whichever method you prefer is good to determine if values are proportional when they're given to us like this. So this next example as well, negative 0.4. So again, I'm just going to type this in, negative 0.4. divided by 1.2, and what does that give me as a decimal? Well, that looks like a negative 0.3 repeating. And then I got 0.6 divided by negative 1.8, which also is a negative 0.3 repeating. Now, are these two values equal? Yeah, they are. So, are they proportional? Yes, they are. Now this can be where it gets a little complicated, all right? And there's a couple ways to do this. But this one says solve for the missing value. So we're saying, so the last question was, are these proportional, right? But this one is saying they are equivalent, they are proportional. Just what value of x is going to make this proportional, all right? So using whatever method you choose, and there are several, but just see if you can figure out the value of x that would make this a true statement, right? So we're not asking if it's equal, we're saying it is equal. We need to make it equal by forcing x to be some value in order to make it equal, all right? But take, we'll say, 45 seconds on this one and see if you can solve for the value of x to make that true. All right, hopefully that was good enough, or a good enough amount of time for you guys to get that. And again, if you get this incorrect, it's okay. We're just starting to learn this stuff. Now, one of the basic methods for this, and it's used mostly when we see values that are, I guess, that we have more experience with, right? So, relevant maybe not be the term to use. But we may just notice values that are related to each other. And in this case, just with this fraction right here, 8 and 48, right? I can see that 8 and 48 are related because if I took 48 and I was going to get the 8, now when we use this method, we're only using multiplication and division. Well, I'll tell you what type of method this is, but 48, what would I have to do to get 8? I'd have to divide it by 6, right? And this is the beauty of scale factors is if I do it to one fraction, I can do it to the other one in order to find missing values. So 12, I would do the same thing, divide it by 6 to get x equals 2. So in other words, to rewrite the fractions, right, it was something over 12 equals 8 over 48. Now that I'm checking this, I would be asking myself, are these actually equal? So now I'm putting a question mark over it just to make sure that I've done this correct. And I do 2 divided by 12, which gives me 0.16 repeating. Then I do 8 divided by 48, and I should get the same decimal, right? Which it does in my calculator. Now, that's one way to use, this is called scale factors, you guys, which we've talked about already, because I'm just scaling a fraction a certain way, even though it's inside the fraction. But I've worked up and down, specifically upwards, to divide by 6. But I could have worked the other way around as well. So 48 and 12 have a relationship. I know if I take 48 and divide it by 4, I get 12 also. So I could have taken the 8 and divided it also by 4 to get 2 as well. And I would have gotten the same answer. So scale factors work up and down and left to right inside of the proportion. And I can't say this enough, because we're going to be seeing proportions quite a bit, not only in this class, but in 980 as well. Proportions are equivalent fractions. And right now we're seeing fractions that are pretty applicable, and we may have or find use of these types of fractions, but like when you get into 1010, you're going to be dealing with more complex type fractions. So there's 4 basic methods that we use in solving proportions, and we just saw scale factors. You could use principles of equality, so hopefully everyone remembers, as long as you do the same thing to both sides of the equal sign, then you can maintain equality, and we're looking at the 4 basic operations. Cross multiplication is the most commonly used method. I personally prefer fish method though, and we'll go over all the other 3. We've already seen scale factors. Now, in that last example, scale factors was pretty clear because we may notice a relationship between the numbers, right? I know 48 and 8, 48 divided by 6 is 8, so I can divide the other number by 6 as well. Or where we saw it was divided by 4, you can divide the other number by 4, okay? But it's not so clear, especially when we look at complex fractions that have fractions inside fractions, or where decimals are in the fractions as well. It may not be as clear. But principles of equality is a pretty solid method. It's just not usually used too often with proportions. But it does create some continuity with principles of equality that we've used to solve equations, because these are actually equations that we're solving. But again, cross multiplication is the most commonly used. I do like fish method because it's pretty quick, but it's an algorithm, so you have to kind of memorize how it works. All right, so let's look at a few methods. The last 3 methods that we have on this one. I'm going to show principles of equality last for this one, because this one is, to use principles of equality becomes slightly abstract and maybe not as direct. So let's start with cross multiplication, because it's a very common method to use. Now with cross multiplication, we do get equality out of this, but instead of seeing this with fractions, we're going to see it without fractions, which a lot of people prefer, and that's why cross multiplication is loved by so many. So by cross multiplication, it means that we're going to cross through the equal sign and multiply the value. So right here, where I've connected the 21 and x, cross through the equal sign, I'm going to multiply these. 21 now multiplied by x. Of course, you could just write that as 21x if you'd like. And then the other cross here would be 49 and 12. So that's 49 times 12. Now, I would want to actually multiply this. 49 times 12. So we'll put that in the calculator, which is 588. Maybe some of you guys knew that. I didn't. Now, this creates a one-step equation for us. And hopefully you remember one-step equations because we're going to see them quite often. 21x equals 588. What would I do to solve this equation? I just divide both sides by 21 to make that 1x, right? So now x equals 588 divided by 21. Let's see what that is in the calculator. 28. Now again, to specify, this means that if I replace the x with 28, I would get equivalent fractions. Okay, so in other words, we're saying that 21 over 49 actually does equal 12 over 28. So again, I can go back to my calculator and check. 21 divided by 49 should be a pretty ugly decimal. It is. But when I type in 12 divided by 28, it should show the exact same value, and it does. So I can see that x being 28 would make these two original fractions equal. Now, to say a word about scale factors on this one, and maybe some of you guys know, like what would I divide 21 by to get 12? I couldn't tell you off the top of my head. Maybe you know. But that's why scale factors aren't always so commonly used with students, especially by the time we get to 950, is because there's not a clear or well-defined relationship between two of the values. Even the 21 and 49, I can see they're both divisible by 7, but I don't know what I would multiply 21 by to get 49, because I'd have to multiply 12 by the same value. So that's why I'm not showing you guys scale factors on this one, because it becomes a little bit more complicated. And again, cross multiplication, like we've seen on this one, it's very commonly used, and most students tend to like it. So that was cross multiplication. Well, what about, I said there's something called fish method. Maybe you've heard of it, maybe you haven't. Maybe you like it, maybe you don't, I don't know. But I'm going to show you guys anyways, all right? And then again, you guys can determine which method you like the best, and we can use that method. By the way, I'm not saying you couldn't use scale factors on this one. You could. It can become more complicated. So, fish method. So I've got my, let's go back to this proportion. I'll use this new one that I'm writing right here. So fish method means that I'm actually going to draw fish over the proportion that we have. Now, am I saying we're going to draw something artistic? I am not. If you guys expected something artistic, I'm sorry. But I'm not artistic, so that's how it's going to be, all right? But if you're like, yeah, I'm going to draw a really nice fish over this, so be it. But in any case, a fish. Well, this is a basic fish, you guys. I'm going to start with the tail, which means that I have to go up and down. Okay, now, before I draw the fish even, just understand that there's 4 values in this proportion, and it's always multiply, divide, and then it's going to equal. Now, it should always equal the letter or the variable that we're using, which in this case is x, right? So I know it's x equals something. It's just a matter of what's the order that we put these in. And again, that's why I say it's algorithmic. And some of you guys are going to like this. Some of you guys are going to say, well, I just really like cross multiplication. It actually ends up being the same thing, okay? So for the fish, I'm going to draw the fish on this, and I'm going to create the tail first. To draw a tail fish, it's just a straight up and down line, you guys. Which means that I always got to go up and down first. Now, since we're solving for x, I need to start with x. And when drawing the fish, I'm going to end at x. Okay, so I'm going to go up to 12. Now, I encounter the 12. That's the first number I encounter, which means it's the first number in the list. Now, to draw the fish, I would cross over downwards like this into the 49. And that's the next number I encounter, so it's the next number in the list that I put into this fish method. Then I've already created the tail. I need to create the head of the fish. And so I'm going to come back around to the 21, which is the next number I encounter. And we should end at the variable, which is x. Now again, some of you guys are like, I really hate your fish. Sorry, man. I did my best, okay? Well, this sets up the problem for us just to type into the calculator. 12 times 49 divided by 21. So what is that? 12 times 49 divided by 21. Oops. Bam, 28. So you see how it gives us the same number, right? It's still x equals 28. Just a different method. In fact, well, some of you guys notice it's the same method though, right? Like we still had up here in green 49 times 12. And then we did that number, 588, divided by 21. So the process is the same. This one is, I think, for me, fish method is just more streamlined. But, again, you get to decide. So you don't have to like, well, you don't have to like either one of these, actually. But hopefully you guys feel more comfortable with one, okay? Now, I said would show the principles of equality last. So let's look at that. So I'll rewrite this 21 over 49 equals 12 over x. Now, without knowing anything else about proportions, okay, and then there's different ways you can manipulate them, but I'm not so worried about that right now, okay? Well, let me specify. This is one of 8 different ways you could write this proportion. But let's not worry about those other 7 ways that you could write it. Let's just say, well, I know this is proportional. I just need to solve for x, okay? Well, what you could do, because I'm trying to get x equals something, but I don't want it in the denominator. And again, this is why the other 2 methods become more useful or used. I actually would need to get rid of the x in the denominator right there. So I would start by multiplying both sides by x, which those x's cancel out into a 1. And to rewrite this one, I really have 21/49 x equals 12. Well, at this point, I would say you'd have to multiply both sides by 49. So 12 times 49 as well. And again, the 49s cancel out. And you got 21x equals 12 times 49. We've already seen that. 588. And then divide both sides by 21 to make it 1x. X equals 28. So we get the same answer. And in fact, we just kind of had to add a step to the cross multiplication from this. But we end up with the same answer. And maybe that doesn't make sense even with using the principles of equality. I first was seeking to kind of isolate the x's, but I don't want x's in denominators. So I had to multiply both sides by x, and then multiply both sides by 49, which is really where we end up with cross multiplication anyways. So you may see or notice the relationship between these 3 methods. But again, I don't really care which method you use, just hopefully you feel more comfortable with one than the others. And that's the one you should use. So let's we've looked at 4 different methods, and all 4 methods would work on this one. But we'll let you guys decide, all right? So look at this problem. Think about the 4 methods we just looked at, and decide which one you want to use, and see if you can find the value of n that would make this a true statement, all right? Give you guys 45 seconds to work on this. 45 seconds, go. So cross multiplication is in. Let's do it. So again, I first start by cross multiplying. It doesn't matter which one you cross multiply first, by the way. But I would be looking at this one as 3 times 0.1 first, which multiplied out would be 0.3. Now it equals the other cross multiplied, 0.6 times n. Now I put this in this specific order, 0.6 and n, because that's how we're used to seeing variables used with coefficients. So it doesn't really matter which order they're in, though, because of the commutative property of multiplication. So 0.3 is going to equal 0.6n. Well, to solve this, I would divide both sides by 0.6 to make that 1n. N equals, that's going to be 0.3 divided by 0.6 in the calculator. Should be 0.5. Right, so in my head that works, but let's just double check. So 3 divided by 0.5. Enter is 6, and 0.6 divided by 0.1 is also 6. So the calculator verifies that we've done our work correct, and that would be our answer. All right, here's another one. This one's kind of unique. Also, maybe not so unique. Okay, you get to kind of decide. But see if you can solve for the value of x that would make this a true statement. Take 30 seconds and see if you can find it, all right? 30 seconds, go. Now, you may think, well, how is this proportional? You don't have two fractions. Well, you do, actually. We're going to make that 11 over 1. Now, we'll stick with cross multiplication because that's mostly preferred. But again, if you guys want something else, just let me know. Now, it's written a little off, but it still works. Okay, so I'm going to cross multiply the 11 and 6. 11 times 6, which is 66. And this should equal the other cross multiplied, which is x and 1. So I'm just going to make that 1x. Well, look, I already have a coefficient of x that's 1, so it's just x equals 66, you guys. This one was nice because it was pretty quick. Now, that was with cross multiplication, which you could use if you're like, dude, I could have done that with scale factors pretty quick, because 1 times 6 is 6, so 11 times 6 is 66. That was pretty quick, right? With scale factors, which is used a little bit less when solving proportions like this, but it's still valid. All right, what about if x is in the denominator? Well, it shouldn't change the method for us, you guys. So x equals 56 divided by 8, which is 7. And like I said, we can go back. I should have checked on that last one. But 56 divided by 7, what is it? I mean, you could even put it as a fraction in the calculator. 56 over 7, which is 8. So we can see that they are actually equivalent. All right, now here we got a complex fraction, 6 over 7/13. Hopefully this isn't a problem. Even with cross multiplication or fish method or whatever method you're using, the process is still going to be the same no matter how you do it. We just need the two fractions to be equivalent by the time we solve for the value of x. So let's stick with the cross multiplication again. And like I said, if you guys want one of the other methods, you got to interrupt me and tell me, okay? Because we can do it. So cross multiplying, I would start with 2 times 7/13. And as fraction multiplication, this would be 2 times 7, which is 14. And 1 times 13, which is 13. So it ends up being 14/13. Then I'll cross multiply the other set, 6 times x. So this is going to equal 6x, right? Well, I don't want 6x. I want 1x. So I'm going to need to divide both sides by 6. So we'll take this and divide it by 6, making it 1x, and then I'd have 14/13 divided by 6. Now I can put that in my calculator, right? 14/13. Then we'll get out of the fraction, divided by 6. And that'll give me the final fraction, which I prefer. This decimal is going to be pretty ugly looking. which is why I don't want it. I'm just going to keep it as a fraction as 7/39ths. Now let's just check, right, because we want to make sure that we've done the work correct. I got 2 as a fraction over another fraction, 7/39ths. And I'll push equals, and it gives me this other fraction, 78/7, which is okay. Because we're just going to compare this to the other fraction, 6 over fraction 7/13. And when I push enter on this one, it should give me the same fraction, 78/7. So they do match, and I can see now that the two fractions are actually equivalent. Now, when is it useful to compare 7/13 as a denominator to the 7/39? I don't know. But, well, I guess you could say on the homework, maybe. So let's read through this word problem here. You need 2.5 cups of sugar to make 30 cookies. How many cookies can be made with 4 1/3 cups of sugar? Now, with word problems, I like word problems because we get to choose how the proportion sets up. Now, like we showed in that one of the earlier slides, it's just two fraction lines that are equal, right? Because that's what a proportion is, fractions that are equal. Now, with word problems, we need to pay attention to the labels specifically, okay? And the two quantities that I'm comparing, because this is two rates, now that it's a word problem, the quantities or the labels that I'm looking at here are cups and cookies. Now, it doesn't matter where you put them in the fraction as long as you keep them there with other fractions that you're comparing, okay? So, cups and cookies, again, it doesn't matter which one you choose. I'm just going to put cups in the numerator. And I don't really know if this is going to be easy or not. I'm just going to put it there, okay? Now, since I have cups in the one numerator, that means I need cups in the numerator of the other fraction. Okay, now I'm not putting values in. I'm just addressing the labels so that I know where to put the numbers. And the other label we had was cookies. I'll just put CK for that. Okay, now again, I have cookies in the denominator for this one fraction here on the left. So I need to keep the cookies in the denominator for the fraction on the right as well. Well, now that I have these labeled, I can start putting in values. And it's 2.5 cups to 30 cookies. So we'll put those values in. It was 2.5 cups. And again, I know this 2.5 goes in the numerator because that's where I put the label cups. And the 30 cookies, that's already cookies labeled in the denominator, so 30 as the denominator. Well, with the other fraction, cups to cookies as a ratio or rate, it shows 4 1/3 cups, and we don't know how many cookies right now. But we do know the cups. And since cups is in the numerator, I'll put 4 1/3 in the numerator. And since we don't know how many cookies, I like to use X just because it's very common. And we've seen it quite a bit. So I'm just going to put X in the denominator. So this sets up the proportion. And where I put the labels will determine how the proportion looks. But even if I switch these, if I had cups in the denominator and cookies in the numerator, I would still get the same answer as long as I have the values related to each other in the same fraction. Okay, and like I said in the beginning, there's 8 different ways to write one specific proportion. So there's 8 different ways to write this one as well, but we're only considering this one as an example. So to solve this, we're going to need to cross multiply, right? So I'll start with this cross. That's 2.5 times x. We'll just make it 2.5x. And by the way, if you made these two mixed numbers improper fractions to start with, that's fine. Now this should equal the other cross as a multiplied, which is 30 times 4 1/3. I mean, you could. I prefer that you guys even use calculators to do these type of operations because That's what they're there for. But if you want to do them by hand, that's fine too. 2.5 as improper fraction, right? 2 times 2 is 4 plus 1 is 5. So it's really 5 halves x. And again, this is only if you're doing it by hand. And then 4 1/3. 4 times 3 is 12, plus 1 is 13. That's 13 thirds times 30. And yeah, we'll make that a fraction over 1, right? So, I'd cross simplify the 30 and 3 to make that a 10. 10 times 13 is 130. Which you would have gotten with the calculator as 30 times 4 1/3 anyways. But this equals 5 halves x. And whether you do this in 2 steps or 1 is up to you, but I'll do it in 2 steps. So multiplying by 2 gets rid of this denominator, which makes it 5x equals 260, 130 times 2. And then finally, divide both sides by 5. Which tells us that x equals, what is that, 52? Now, x is 52 as a numeric value, but remember the question is how many cookies can be made. So since it's a word problem, we need to label this. It appears that we can make 52 cookies. So don't forget to label your answers on these word problems, you guys. So 52 cookies, again, we can just double check. Let's make a fraction with a mixed number here. So 2.5 over 30. Enter, and that's 1/12. That's good. So in other words, it's 1 cup to 12 cookies. Now this is a unit rate, by the way, you guys. And if you use the unit rate, you would have done well, which would be one of the other strategies. So let's make another fraction with a mixed number, 4 1/3. 4 1/3. Now the denominator, we're saying it's 52, should be 1/12, and it is. So 52 cookies appears to be the correct answer. All right, as usual with word problems, I just like to reiterate this, just make sure you read it. So let's look at this, read it. A leaking pond loses 9 gallons of water in 2.5 hours. How many gallons of water will it lose in 16 hours? We'll round our answer to the nearest tenth if it's necessary. So again, we're going to set up a proportion, which means I need 2 fraction lines that are equal. And again, this is a word problem, so we have labels with these quantities, right? We need to label them. And the 2 things we're comparing here are gallons and hours, right? It says 9 gallons of water in 2.5 hours. Now again, it doesn't matter where you put the gallons. Okay, so if you're like, look, I want my gallons in the numerator. All right, feel free to do it. Okay, if you want your gallons in the denominator, like this, not a big deal. Okay, now, well, since I erased the one in the numerator, I'll just keep it like this. All right, just remember, if you have it in the denominator, keep it in the denominator. So I'm going to put gallons in this other denominator. So wherever the labels are in the fractions, they need to stay there. And the other quantity I'm comparing is hours. So I have hours to gallons and hours to gallons. It needs to be the same comparison straight across. Otherwise, you're not really, you could be comparing equal things, but it can throw the calculations off. So in this case, it said it was 2.5 hours related to the 9 gallons. So there's my first fraction, 2.5 hours to 9 gallons. Now this equals, this one was 16 hours. But we also don't know how many gallons it would lose in those 16 hours. So I'm using X. You could use whatever letter you want. And this sets up the proportion for us to solve. So using cross multiplication, right? I got 2.5 times X. It's pretty nice. And then the other cross multiplied 9 times 16, which is, we'll just go to the calculator to make sure. I feel like if I do that in my head, I'll get it wrong. So 144. So 2.5x equals 144. Let's finish this off by dividing both sides by 2.5. So that'd be 1x equals 144 divided by 2.5. Again, just in the calculator, 57.6. So this is already rounded to the nearest tenth. But again, don't forget to label this. This one is in gallons. Yeah, let's show that. So the other way would have been, right, to say, well, I want the gallons in the numerator. So I'm going to keep the gallons in the numerator and the hours in the denominator. Well, we started with 9 gallons in 2.5 hours. So if this goes for 16 hours, we just don't know how many gallons that is. So this is 2 of the 8 ways to write a proportion. And we'll use the same method because it doesn't really matter. Right? And we can see it's the same multiplication. It just may change the side that it's on. So, yeah, right? You see that? 9 times 16 is the 144. And then the other cross multiplied, still 2.5x. So, and, you know, we can see this is going to end up at 57.6 gallons. But, yeah, we can see that the order of this, well, it does matter. But when we cross multiply, it ends up being the same values, which is why there are so many different ways to write a proportion. And it also doesn't matter if you have gallons in the numerator or denominator. You're going to still end up with the same proportion either way.